Hello everyone, welcome to my channel. So today we are going to do Leetcode CPP challenge. Lar- and its first question, largest positive integer that exists with negatives. So let us first read this question and after that we will go ahead with the constraint and then about the coding part of the same. So yeah, before starting with this, let me introduce you with coding challenge of Newton's tool. So about the same you could figure out in the description below and regarding the same you can find each and every details in that particular link. You can register there for free and then if you are the top performer of that competition then surely you will be getting some exciting prizes. So and even about those prizes also you can figure out in the link only. So this was all for the same. Now let's start with this question. So here, given an integer array nums that does not contain any zero, find the largest positive integer k such that minus k also exists in the array. And then return the positive integer k if there is no such integer, return minus 1. So the thing is that this array which is being given to us, so what we are required to do is positive, if positive number is given to us, then we need to check that does its negative number exist or not. And the second thing we need to check is that if that positive number is the largest positive number in this whole array or not. So this is the thing which we are required to check. Basically, a pair should exist and those pair consist of positive and positive's negative number. That should exist. And in all those pairs, whatever is the most, you can say largest positive number that we are required to return as our answer. So here in this particular example only, minus 1, 2, minus 3, 3. So basically minus 1 is not existing, 2 minus 2 is not existing. But minus 3 also exists and 3 also exists. And out of that, 3 is the, uh, you can say the largest out of all which is being there, right? And then in the second example, minus 1, 1 also exists. 10, then minus 10 doesn't exist. 6, then minus 6 doesn't exist. But for 7, minus 7 exists. So that's why 7 would be our answer. So like this only we are required to check for all the other in the given input, right? So let us check for the constraint and then after that we will be going there with the coding part. So here basically you can see that it could go up to 1000. So that's why n square and even yeah, n square solution would easily work here, but we will try not to make it in n square. And then here, that each number is in the range of minus 1000 to 1000. So number integer range is also much smaller, and number is never equal to 0. So that is also the thing. So now comes the part that how we are required to do this particular question. So for doing this particular question, now the thing is that we will be see how we can do. If we check here that this particular number is there, right? So we also need to check that does 1 also exist in this particular or not. If it doesn't exist, then we don't need to do anything for the same. But if exists, then we need to check that if the previous number which was stored in our maximum variable was that the maximum or the present number is it that the maximum. So that's the thing which we are required to do. So this is how we will be proceeding in this question. So now let me show you the coding. Should I show coding part directly? So let me show you first about the explanation, then we will be going ahead with the coding part. So here because okay, 1 minute. Okay. So here let us take the first example 1 minus 1, 2, then 3, then minus 3 is right. So what we can do is like here either we can sort this array, right? But after sorting, what we will be doing, right? We can check by 2 pointers in these, right? But when we will be checking, there could be some instance like that also, that when here it would have been minus 4, right? So when we check here, and how many times we would be checking for the same, right? So that's why I avoided that two pointer approach here. And even sorting of this particular, I thought that let us take some auxiliary space only. And after taking auxiliary space, what we can do is we can directly push every element which is there into a set, right? So after these elements come into set, or even we can optimize it further as per the use case. Presently, we are just taking set. So now we have taken a set. Then after that, what we can do is we will be checking. Means we will be traversing from this. We'll check that does 0 minus set dot contains, not this here. We'll be writing here. Num. Does this exist? If that exists, then we will be checking for our answer that what is maximum out of this. So answer comma our nums that we will be checking. So as per this conditions only, we will be able to figure out with our final answer. So this is a main approach which I had used during my contest. But although this could be optimized more further, now let's go with this only. Then I let you know with the optimized approach. So here, this maximum, we are starting with the int min, and then after that, here we can use unordered map as well. So now first thing what we are doing here is we are directly filling up the unordered map, and then we are traversing that. If it is less than 0, then we are required to check 0 minus nums I basically for both of them we are required for the same, but the only condition at which we will be checking that is it greater or lesser. So for that purpose, we will because when it is greater, right? So here we can directly check for nums of 0. But if it is basically less than 0, then at this particular point we will be checking for 0 minus nums of I. Uh, yeah, if it exists, then in that case only. But earlier solution was also working, that's the case. But let us first run this, that it just works or not. Yeah, it got accepted. So this will also work, and even if you don't put here like this, I can fill up that. That is what I'm thinking for the same. Okay, if it means even if it is less than 0 or greater than 0, see here only we can obtain means shorten the code, the length of the code. Here we were traversing that, right? So what we were doing was we were checking that if it is less than 0, right? Basically a negative number. So we will be checking for the negative part of the same, that does it exist. If that exists, then we will be directly maximizing the same because our next step would be that only, right? And same we are doing for this part as well. Earlier I was saying that here we are required to write 0 minus something. So that's why I had put like this. But now as you have checked that we can also optimize this into the smaller version. We require this. Hmm. So now what I have done is that let us submit this first. At, submit the actually I'm coding it live only. Okay. Okay. We are required to have this because I'm just checking for this if condition only. That's why I never submit first compilation error. Now it works. So here, see what I was saying was we can directly eliminate that condition as well. So that I've already eliminated. Yeah. So here the thing is that directly we can check that if that particular means whatever num is there, basically we need to check that if one is there, so minus one should exist, and if minus one is there, so so one should exist, right? So that only thing we are checking that if that particular is a negative number, so after negating its sign, we are checking that does it exist. if it exists, then we are whatever is the positive number of the same, we are checking with I mean comparing with that and updating our answer. And then if it is positive number means that is it is one. So we are basically negating it so that we can check for its negative part. And if that negative part exists, so we are basically means comparing with the number as it is and going ahead with the same. So that is what we are doing here. So this is what we will be doing for this particular. Means first we are storing in our unordered map. So again, sorting is not required. We are just using it as a hash so that we can check that does that number already existed or not. Because if we would be having check from this nums as it is, so the only issue here was that in unordered map we are able to check for each and every number in order of one operation. But in a vector we are not able to check in that manner. So that's why we are using unordered map. Just auxiliary space is used here, but the time complexity, because of this only, it is order of n. This hashing part is order of 1. And then at the end, how we are doing this is, so at the starting, I had taken it as int min only. So that because there are some cases where we are not able to get an answer. So there we are required to return -1. So that's why I've initialized my answer is -1 only. And I'm checking that if my int min is not means my max is not equals to int min, so in that context I'm updating my answer, else I will be returning -1 only. So this is why I've taken here int min, so that this max, if in the scenario it is not updated, so in that particular scenario we will be returning this as it is. So this was all about this particular question, although by flow only, by explaining only, I came to know that I can optimize it more. So like this only, it's better to cross-verify your own solution so that you can come up with more optimized solution during that run time or dry run cases only. So that's the thing. Like this usually happens in my interviews as well. Means in my last interview, this only happened when I had optimized. So it goes with flow. So it is a process only. So yeah, this was all for this particular question. If you have any doubt even about this question or any other question, you could comment that down. I'll try to solve them in the comment. And yeah, if you like this explanation, please do like and subscribe to my channel and also do share among your friends. So this was all. Thank you.